Good morning everybody. Today I am going to present a lecture on differentiation under integral sign. So this is a video lecture for the program BSc, subject mathematics, semester 5, session 46. So this is the learning objective. These are the course outcomes. These are the prerequisites. So let us start differentiation under integral sign. So there is a theorem. If f of x comma alpha and dou f by dou alpha are continuous functions of x and alpha for alpha less than or equal to x, for a less than or equal to x which is less than or equal to b, then c less than or equal to alpha which is less than or equal to d, where a and b being independent of alpha, then dy d alpha of integration from a to b f of x comma alpha dx is equal to integration from a to b dou f by dou alpha dx. So here we prove the theorem by using Lagrange's mean value theorem. So for that, first we consider f of alpha. Let f of alpha be is equal to integration from a to b f of x comma alpha dx. So let us consider this one as f of alpha. Now give a small increment to this function f of alpha, so which gives f of alpha plus delta alpha is equal to integration from a to b f of x comma alpha plus delta alpha dx. Now call this equation as 1 and this equation as 2. Now subtracting 1 from 2, then we get f of alpha plus delta alpha minus f of alpha equal to integration from a to b f of x comma alpha plus delta alpha dx minus integration from a to b f of x comma alpha dx. So this is equation 3. We now apply Lagrange's mean value theorem for derivatives. We get f of x comma alpha plus delta alpha minus f of x comma alpha is equal to delta alpha into dou by dou alpha of f of x comma alpha plus theta delta alpha, where 0 less than theta which is less than 1. Now call this equation as 4. Next, from 3 and 4 we write f of alpha plus delta alpha minus f of alpha is equal to integration from a to b delta alpha into dou by dou alpha into f of x comma alpha plus theta delta alpha dx. Now taking delta alpha common, so which gives delta alpha integration from a to b dou by dou alpha f of x comma alpha plus theta delta alpha into dx. Now dividing throughout by delta alpha, so which gives f of alpha plus delta alpha minus f of alpha divided by delta alpha is equal to, now integration from a to b dou by dou alpha f of x comma alpha plus theta delta alpha dx. Now this is equation 5. Now taking the limit as delta alpha tends to 0 both sides. Now after taking the limit as delta alpha tends to 0, this gives the df by d alpha. Okay, df by d alpha. So that is df by d alpha is equal to limit as delta a tends to 0 integration from a to b dou by dou alpha of f of x comma alpha plus theta delta alpha dx, which is equal to integration from a to b limit as delta alpha tends to 0 dou by dou alpha f of x comma alpha plus theta delta alpha dx. Now this is equation 6. So again we have written this by principle of first differentiation. First principle of differentiation, limit as delta alpha tends to 0 f of alpha plus delta alpha minus f of alpha by delta alpha is equal to df of alpha by d alpha. So now from 6 and 7, now again limit as delta alpha tends to 0 dou by dou alpha of f of x comma alpha plus theta delta alpha dx. So when you differentiate this, apply limit as delta alpha tends to 0, we get this as dou by dou alpha of f of x comma alpha, because delta alpha is going to 0. So here we substitute delta alpha equal to 0, which gives dou by dou alpha of f of x comma alpha. Now call this equation as 7. Now from this equation 6 and 7 we write df of alpha by d alpha is equal to integration from a to b dou f of x alpha by dou alpha dx, or d by d alpha of integration from a to b f of x alpha dx is equal to integration from a to b dou f of x alpha by dou alpha dx. So this is the proof of the theorem. So next we have a problems. The first problem is assuming the validity of differentiation under integral sign, the value of the integral 0 to pi by 2 log 1 minus x square sin square theta d theta is equal to, this is the first option, this is second option, this is third option, and this is fourth option. So you have to choose the correct answer. Next, second one, assuming the validity of differentiation under the integral sign, integration from 0 to pi log 1 plus a cos x divided by cos x dx is equal to, the first option is this one, this is the second option, then this is the third option, and the fourth option is none. So find out the correct answer by solving the problem. Third one, assuming the validity of differentiation under integral sign, integration from 0 to pi log of 1 plus sin alpha cos x by cos x dx is equal to, the first option is pi sin inverse a, second option is pi alpha, third option is pi cos inverse a, the fourth one is none. Next, fourth one we have, assuming the validity of differentiation under integral sign, integration from minus pi by 2 to plus pi by 2 log 1 plus a sin x by sin x dx is equal to, the first option is pi sin inverse a, second is pi alpha, third pi cos inverse alpha, fourth one none. Next, last problem, assuming the validity of differentiation under integral sign, integration from 0 to infinity tan inverse ax by x into 1 plus x square dx is equal to, the first one is pi sin inverse a, second option is pi by 2 log 1 plus a, third option is pi cos inverse a, fourth one is none. So you have to find the correct answer by solving these problems. So these are the reference books. So now with this session I conclude my session. Thank you, and continue in the next session.